Mr. T, and we're going to talk about two applications on the unit circle, or actually on circles in general: arc length and area of a sector. So let's talk about arc length first. So we are talking about being able to calculate the length of this arc on the circle. If it's like a piece of string, we straighten it out and measure it. So let's think about how we might come up with a formula for that. This is part of a circle, and if theta was all the way around, 2 pi radians all the way around, the length of the arc would be our circumference. So the entire length of the arc all the way around is 2 pi r. Now our arc is only a fraction of the circle, so we have angle theta here, and its portion, or the ratio of this part of the circle, is going to be theta to the entire circle would be 2 pi, so theta over 2 pi. We can see the 2 pi's cancel out, so we come up with our formula that arc length equals r theta. Now this formula only works, and a common mistake that some of you make, only works if theta is in radians. It's very important. Because let's look at what would happen if we did this same thing and assumed theta was in degrees. We would have our circumference would be 2 pi r, and then our fraction or portion or ratio of our arc would be theta over 360 degrees. So we could maybe cancel out a 2 and make this 180, but we get the formula pi over 180 times r times theta. Not as simple as a formula. Now we could use this if theta was in degrees, but normally the way we do it is we would use the pi over 180 to convert degrees to radians and then use our formula. So this is going to be the formula that we want to use for arc length, and just again remember that theta is in radians. Our second application in terms of formulas that we're going to talk about here is going to be sector area. So we're talking about finding the area of this sector, and we can use kind of this same scheme here of a proportion or a ratio. So the total area of the circle is pi r squared. And again, we have a fraction of the circle, that's theta divided by 2 pi. That's the proportion of our sector to the whole circle. We can cancel out our pi's, and so we get a formula here that the area of a sector is equal to 1/2 r squared theta. And again, for the same reason we talked about here, theta must be in radians. So let's apply these two formulas, our arc length formula and area sector, to a couple application problems. We use these on rotational problems. So let's look at an example. Sorry, my scan of this picture got destroyed, but a number of years ago my wife and I went to Seattle and went to the Space Needle, which was put there during a World's Fair, and there's a restaurant that's up in the saucer part of this, and that restaurant rotates, and it tells here that it completes 1 complete revolution every hour. And if you make reservations, you can get a seat on a table right on the outside of this along the windows, and you can sit there and dine and see the entire panorama of Seattle, the Olympic mountains, and you can see Mount Rainier in the back. It's really a gorgeous place. So if you ever get a chance to go to Seattle, you might want to eat there. But let's solve our problem here. So we ate dinner, and we were at our table along the window from 6:42 to 8:18. So let's see if we subtract that. So this is, we make this 7 and 78 minutes. So we've got here, 36 minutes, and 1 hour and 36 minutes is how long we stayed at dinner. Or if we make that as a decimal of hours, that would be, let's convert our 36 divided by 60, and then add 1 to that, so that's 1.6 hours. And since we have 1 revolution per hour during our dinner, we set through 1.6 revolutions. Or in terms of angles, we have 1.6 times, so revolutions, times 2 pi radians per revolution. So our revolutions cancel out. So we have 3.2 pi is our theta. Now here our radius, and unfortunately that number, our radius, which you can't read there, is 47.25 feet. So they're asking us how many feet did we revolve, how many feet did we travel. That's an arc length, so we know our arc length is going to be r times theta, or 47.25 times, that's feet, times 3.2 pi. So let's do that in the calculator. 47.25 times 3.2 times pi. And we come up with 475 feet. You might be interested in how fast we're traveling. So we can use our DIRT formula. Distance equals rate times time. Rate is our speed. So in our case, we know we traveled 475 feet. And we're trying to find our rate, and it took us, what did we say, 1.6 hours. So our rate, if we divide, is going to be 475 divided by 1.6, which is, let's just round it, say 297 feet per hour. And let's say we wanted that in miles per hour, so we have to convert miles to feet, 5,280 feet, not meters, miles. So our feet cancel out. So if we take that number and divide it by 5280, we come up with 0.06 miles per hour. So you really don't even feel or notice you're moving that fast when you're sitting there. Okay, so this was a arc length problem. Let's talk about area of a sector. So on your rear window of your, say, SUV, we've got a wiper, and it's sweeping out a area here. If we add this extra circle here, and we're wanting to know this area. If we draw this on a circle, we've got this shape, which is here, but we have to cut out that area here that's not covered by the wiper, because the wiper doesn't come all the way down to the center. So we're cutting out this piece here. So we want only the shaded piece in here. Now we could find the area of the entire sector and subtract our red area. Now we're told that this total length here of the wiper blade is 25 inches. And this part, we're told, is 14 inches. That means this red part, if we subtract 14 from 25, is 11 inches. So our total sector area is 1/2 times radius squared times theta. Now we know the radius here is 25 inches. Now we need theta, but remember it's got to be in radians. So we've got to convert our 120 degrees into radians. So we have to multiply by pi over 180 degrees. Our degrees cancel out. 0. 6 goes into 12 2 times and 3 times. So we have 2 pi over 3 as our theta. And R again for the entire sector is 25. So our total area of the whole thing, not taking out this red part, is 1/2 times 25 inches. So that's going to be 25 inches squared. So we're going to have the right units. Times 2 pi over 3. I forgot to show the squared here. So let's calculate that. So 0.5 times 25 squared times, let me just put this in parentheses, 2 pi divided by 3, and we come up with 654.5 square inches. Now if we find the red area, we need to take 1/2 times 11 squared times the same angle of rotation. So let's redo that calculation. We can bring that up using second entry and change our 25 to 11. And we get a 126.7 inches squared. So to get our final answer, we said we wanted to subtract the red area from the blue area. So we get here 8, 6 from 3 is 7, 2 from 4 is 2, 1 from 6 is 5, 527.8 square inches. So we've seen here an application of arc length and sector area, and again the key point, remember our angle of rotation must be in radians.